Dear students, last week, as you know, we discussed about Thomson, Rutherford, and Bohr's atomic models. Today, we will further discuss about Bohr's model atom because it is related to somehow related to your electronic configuration. Okay, so in this figure, you can see easily. First, I briefly explain about Bohr's model atom as in 1913. Okay, in 1913, Niels Bohr, 1913 Niels Bohr, which is a Danish physicist, proposed a new model for hydrogen atom and hydrogen-like atoms, known as Bohr's model of atom. So this model successfully explained the stability of an atom and the atomic spectrum of hydrogen. Okay, before the model which come before Bohr as Rutherford model and Thomson model. Okay, so this is the model which explains the stability also. So now I'll explain some postulates of Bohr's metal atom. So first is that this model explain, okay, some assumptions are given by Niels Bohr. That first is the motion of electrons around the nucleus take place in certain specifically permitted circular orbits or closed orbits known as energy levels or energy states. Okay, so this is nucleus, as you understand now from its Egyptian. Okay, so these rounded structure, okay, these all are which you seen. Okay, these are the orbits or energy levels or energy states, you can anything say that. An electron in a particular energy level has a defined amount of energy. Okay, so every electron has in a energy level has a fixed amount of or definite amount of energy. These energy levels are numbered as n is equal to 1, 2, 3, 4, etc. Okay, or can be designated as KLN, MN cells. Okay, I already told you that this is nucleus. So first cell, okay, in this two electrons are here. So first cell is K. Okay, second one is L. Okay, third one M and N, then so on. So this type of energy cell we can represent around the nucleus. Okay, the energy level closest to the nucleus is numbered 1 or designated as K. Okay, so which is more close to nucleus. This is nucleus. Okay, this is nucleus structure, and this is the first cell. Okay, and it is designated as 1. Okay, number given is 1 and designated as K. Okay, alphabetically is called K cell. Then second number L, third M, and 4 for N. Okay, like this respectively. So this is the first assumption. Second is during its electron motion in particular energy level or energy state, an electron neither lost nor gain energy. Okay, so you have to understand that in this energy level, when an electron in this energy level, okay, in a fixed direction, it cannot lose and its energy or not gain. The energy of an electron is particularly energy state always remain fixed or stationary. It means that if an electron is not disturbed, okay, it will move in a particular orbit forever. Okay, so you have to understand that in atom this is nucleus. Okay, so this electron, if it revolve around K cell, it remain as it is. Okay, it revolving as it is forever in this orbit if it undisturbed. Okay, the energy of an electron remain fixed or stationary in orbit, and therefore the energy states are also referred to as stationary energy states. Okay, that's why it's called, because the energy of electron remain fixed or in stationary. Okay, stationary in a orbit, that's why it is also called as stationary energy states. Only certain, third assumption is only certain discrete energy levels or energy states are permitted, and angular momentum of an electron in an orbit is can be quantized. Okay, we can quantize only angular momentum of an electron. Okay, it is given by the rule MVR. Okay, I write here MVR. Once again, MVR is equal to n h upon 2 pi. Okay, So this is the formula to quantify the angular momentum of electron in a orbit. So where n is an integer, so n is a integer in this. Then an electron may jump from a lower energy level to a higher energy level. Okay, from a lower energy level to a higher energy level by absorbing energy, or from a higher energy level to a lower energy level by emitting energy. So the energy loss or gain during these transitions is always equal to the difference of the energies of the two levels involved in the transition. Okay, so by absorbing energy, okay, so it can be goes from lower energy level to high energy level, and if it loses its energy, then it come to the lower energy level, okay, by emitting its energy. So the if quantitatively we write it, delta E is equal to E n2 minus E n1, okay, E n2 minus E n1. Now I tell you that how electron distribution takes place in orbit. Okay, so first, as you know that there are two rules for that. First, electrons reside in cell. I already to explain it about you, and 2 1 square rule also explained in last class. So electrons in an atom move around the nucleus in certain well-defined imaginary. On these orbits are imaginary. Okay, orbits or cells. These cells are designated as K, L, M, N, O, etc. Okay, so these are the cells. I already tell you. I write also here K, L, M, N. Four are given here. For example, while moving in a particular orbit, an electron is associated with a definite amount of energy. Therefore, the orbit also referred to as energy shells or energy levels. Okay. Then the energy of an electron increases as the distance of the cell from the nucleus increases. So you have to understand that in these four cells, which has more energy? Obviously, N have more energy. Okay, nucleus is here, it is far away from nucleus, and lowest energy for K cell because it is closest to the nucleus. The energy of an electron in L cell is higher than in K cell, but lower than that of in M cell. Okay, the energy of L cell is higher than for K cell, but lower than is M cell because it is far away than L cell. So the electron in an atom are distributed in various orbits in a definite fashion also. Then the word come electronic configuration. Okay, so what is electronic configuration? The distribution of electrons in different orbits. Okay, so you can see here these are rounded structure shown electron here. So this is the first energy cell, K cell. Okay, in this you can see two electrons are revolving here. Okay, so it's you can see that the distribution of electron in orbits of an atom is called electronic configuration. Okay, different orbits, how many electrons are revolving in different orbits? Suppose it has four cells. Okay, so these electrons are revolving around it. Okay, so this is the electronic configuration of that atom. Then one 2 n square rule, which I already explained you. Okay, that first orbit has the maximum number of electron will be 2 because number of cell is 1. Okay, as you know that number of cell is 1 here. So if we write it as 2 1 square, 2 into 1 square is equal to 2. Same for second orbital, 2 is here, 2 into 2 square is equal to 8. Third orbit has M cell have how many electrons then? Then it has maximum 2 into 3 square is equal to 18. So 18 number of electron there. Fourth orbit, okay, which is N cell. Okay, for N cell 4, so 2 into 4 square is equal to 32. So there are some rules for N. So maximum number of electrons that can be accommodated in a particular orbit. Okay, in a orbit only 2 n square number of electron can be, you can say, remain. Okay, can be accommodated only 2 n square number of electrons. Then second rule is the outermost cell of an atom can never have more than 8 electrons, and the penultimate cell orbit next to the orbit can never have more than 18 electrons. Okay, so you have to understand that if it has 2 electrons here, okay, then the outer its next cell will be 8 electrons, and next will be 8, and then it will be 18 electrons. Maximum number of electron can be 18. It is not necessary that a new cell formed when the previous one is completed equal to 1 square. A new cell is formed as soon as the outermost cell attains 8 electrons. The outermost cell cannot have more than 2 electrons, and the penultimate shell more than 9 electrons, so long as the next inner orbit is not complete as per rules 1 and 2. Okay, so there are can some exception also there. We will explain and understand with an example. So the example is structure of potassium atom. The atomic number of potassium, as you know, K is equal to 19, okay, and its mass is 39. Since it is a neutral atom, it contains number of electrons. How one number of electron? Number of electron is 19. Okay, number of proton will be also 19, because you know that number of electron is always equal to the number of protons. So both are 19. Then number of neutrons may be, number of neutrons is equal to A minus Z. It means atomic mass minus atomic number. So 39 minus 9, okay, 39 minus 19 is equal to 20. So these are the number of electron, proton or neutron. Okay, I already explain you how to calculate the number of electron, proton and neutron. Okay, then the nucleus of potassium contains 19 proton and 20 neutrons. As you know that nucleus has proton and neutron only, and electron are revolve around it. Okay, so 19 proton and 20 neutron here. So according to rule 1, first rule is number of electrons in K cell will be maximum 2. Okay, because when we write its configuration, okay, according to rule, it's first you have to understand whenever you going to write about the electronic configuration. Okay, you have to write its number. 19 is its atomic number. Okay, so how can you write it? First number of electron, K cell have how many electrons it has? Only 2. You can see 1 2, so first you have to write it as 2. Then second cell, L cell, 2n square rule, you have to remember always 2n square rule. Okay, so 8 electron will be there, so it can be 2 8. Okay, now how many electrons are left there? 9 electrons left. So in remaining third cell can accommodate 18 electrons. Okay, M cell can accommodate 18 electrons, but potassium has left only 9 now. So what you have to write? 2 8 9, last one is 9. So its electronic configuration would be 2 8 9. Like this you have to write. Okay, but rule 2 you have to understand first. Okay, so since the M cell is the outermost cell, it should not have more than 8 electrons. Okay, it is the rule. So what you have to write? Hence according to rule 3, the new cell, that is N cell, should begin to form one and should contain electrons which is an extra. Okay, extra in the M cell. So thus the electronic configuration is potassium is, what is the configuration? We can write 2 8, then 8, then 1, because maximum number of outermost electron can be a cell have only 8 electron. So we have to write like this. Okay, not like this 2 8 9. Okay, this is wrong. This is the right one, electronic configuration. Like this you have to understand the electronic configuration. Okay, in your class you have to understand only atomic number 1 to 20, at least you have to understand. Okay, I will share with you a table that you can explain understand well. So in this table some electronic configuration of elements will be given. Okay, so for hydrogen atomic number, as you know, okay, atomic number is 1. So mass number is also 1, its mass number is also 1. Okay, so number of fundamental particles, that is proton, neutron, okay, and electron should be, electron number is related to the atomic number, so it's 1 here, and proton also 1. So A minus Z is nothing, 0 will be there, and shell will be K cell, only 1 electron is there. Okay, then helium. If you see for helium, atomic number is 2, mass number is 4 given. Okay, so number of fundamental particles, how you calculate? Electron should be 2, because number of electron is always equal to the number of atomic number. Okay, and proton would be 2, because electron and proton are same, number of electron is equal to the number of proton, so it's also 2. Then A minus Z you have to do, so 2 minus 4 minus 2 is be 2. So cell will be, because 2 electrons are here, so cell will be K cell, because K cell can accommodate maximum 2 electrons. Then for lithium is also So I will take one more example so that can you understand more well. Okay, suppose for this nitrogen, okay, nitrogen atomic number is 7, atomic mass 14, so its electron also 7, proton also 7, and its neutron should be 14 minus 7 is 7. Okay, and shell, how can you know shell now? It has 7 electrons, so first can accommodate maximum number of 2 and second should be 5. Okay, so its outermost electron will be 5 because 8 number, till 8 number can be a cell accommodate. So you have to understand that till the fluorine it's 7 we can write, okay, till neon 2 8. But for sodium, why we writing 281, you can understand that now. Okay, because outermost cell can accommodate only 8 electron, maximum number of electron, then next electron should be going to the next one. Okay, like this you have to understand. For calcium you can understand, okay, 2882, these are the electronic configuration in last KLMN. Okay, 2882 is the electronic configuration of calcium. Like this you can understand. Then atomic structure of element with atomic number 1 to 20 are also given in your book. So for hydrogen you can see one example. If you take only for hydrogen, you can easily understand. Atom is 1H1, okay, number of proton 1, electron also 1, so mass number, okay, is also 1. Then neutron should be 1 minus 1, so 0 neutron will be there. Electronic configuration will be 1. Okay, so its electronic configuration will be 2. For helium same, 2 proton 2 neutron. Okay, 2 electrons will be in the outermost shell. And for lithium, okay, electronic configuration should be 2 and 1. Okay, here 1 electron is can be shown, okay, not given here. Then you can see for beryllium, okay, 2 electronic configuration 2 and 2. Okay, 2 electrons are in one cell and 2 electrons are in second cell. Atomic number is 4, okay, and mass number is 9, so its neutron number will be 5. 9 minus 4, proton will be same as electron 4. So electronic configuration outermost cell 2 and 2. Similarly for boron, okay, boron, now you can understand, I hope, that atom of boron is written as B5, atomic number, mass will be written as 11. Okay, so atomic number is 5 happen, okay, mass number is 11, then its proton will be 5, same as atomic number, and mass number 11 minus 5 is equal to 6. So 6 proton 6 neutron is there. And electronic configuration, okay, electronic configuration 2 and 3, because how can I write it? 2 and 3. 2 electrons are in first cell, second one is 2 and 3. Okay. According to atomic number, you have to make the electronic configuration. Okay. For carbon 2 and 4, and 2 5 for nitrogen, oxygen 2 6. Okay. And for uh, fluorine 2 and 7, okay, 2 8. Then for sodium 2 8 1, because second cell can occur, we are not writing it as 2 9. Okay, atomic number is 11, we are, why we are not writing 2 9, because outermost cell can be accommodated only 8 electrons, so 2 8 1. Like this for magnesium 2 8 2, and for aluminium 283, okay, 284. And for silicon, okay, phosphorus 285, and for sulfur 286. 287 for chlorine, 2888 for argon, 28881 for potassium, and 2882 for calcium. Okay, you have to learn them and try to understand and make their atomic structure. Okay, how can we represent it as in this orbit? Okay, so 2 electron in first cell, you can see 2, second cell have 8, and third also have 8, and last one have 1 electron right there, like this. Okay, in this also first cell have 2, okay, 2 you can see here, and second 8, third 8, last one 2 electrons. Like this you can write the electronic configuration also. So I hope you will understand till here. Further things we will discuss about isotopes and isobars in next class. Thank you.